Okay guys, let's take a look at today's lesson. Today we are finally going to get to prove trig identities. This is an exciting day, yay! Okay, so let's talk about that. I have some steps up here. We've been easing into this for some days now. You know, we spent a day on simplifying trig expressions. We learned about using identities and such. We spent the last lesson on transforming, right? We had one thing, we wanted to make it look like another. These are all building up to today where we're going to actually do proofs, where we're going to have one trig expression equal to another one. Okay? So we do a specific kind of proof. I think it's a bit more formal than some textbooks, and some people do something a little differently. What some do is they work both sides down until they get them to be equal. That's not really what that is proving by like transitive property. If this equaled that and that equaled that, which equals this, then you see how it just kind of breaks down, and then this, you know, this would be this. All right, that's not what we do. We do a more formal, I think it's a more formal proof. We work one side. We work one side and we transform it to the other side. Okay, so the very first thing that we have to do is we have to decide which side we're working. Yesterday you were told which you were going to work on. Today you get to pick. You could choose either side. It just really, my recommendation to you would be to choose the more complicated side to simplify. That usually will, you know, your choice is to shrink something down or make something bigger. Normally for us it's easier to shrink something down than make something bigger. So that would be my recommendation to you, is to choose the more complicated side to simplify. Now when we work on whichever side we're choosing, we have a couple of different things to do. We can look for algebraic things to do, and we can look for trigonometric things to do. We have those both. We have to keep both of those in mind. So let's talk about some algebra things that you might want to do. You know, you always want to be looking at where you're going, focusing on where am I going. If I have two terms in the side that I'm working on and I need to get down to one term, I could add fractions together, or I could do a Gcf factoring. You know, factoring is a thing, right? So as some of us kind of gloss over that, but Gcf factoring, factoring out the greatest common factor, is really a pretty powerful thing for us to be able to do. So we need to keep that in mind. Well, maybe I want to do this. Maybe algebraically I want to multiply by a clever form of 1. What is a clever form of 1? Well, there's several examples. We looked at finding a common denominator, right? That would be different ones for the common denominator. We also looked on a problem just a few minutes ago to multiply by the conjugate, and that certainly is helpful at times. And we can't just multiply by the conjugate. It has to be by the conjugate over itself, right? It has to be the number 1. We can multiply by 1 all day long, but we cannot multiply by anything else. You know, maybe we want to get a particular expression in a numerator or denominator. Maybe we want to take something and make it bigger rather than make it smaller. You know, maybe we want to multiply by, I don't know, tangent plus sine over tangent plus sine for some reason. You know, I don't know. But you have options. You have an unlimited, really, amount of options that you could do. So you certainly are allowed to multiply by that. It's 1. It's a crazy looking 1, but it's still 1. So that's an option. We might want to distribute. You know, we might want to do some obvious algebra things like multiplying things out. Or now I want to be specific about this because I had questions about this earlier. Squaring. Squaring, it doesn't mean that we're allowed to square things just indiscriminately, just whenever we want to. This means that maybe we have something like on that problem on the yesterday's daily work. Maybe we have something that looks like this. You know, that's squared. Maybe we want to go ahead and, you know, square it, multiply it all out. It's really talking about distributing or multiplying. Okay, so that's what it means by squaring. Not that you're allowed to just square something because you want to. It's something that would have been squared that you can work out. Does that make sense? You're not adding squaring in, you're just doing whatever is there. That's what this is talking about. As far as trig things to do, we want to look for familiar expressions. Hopefully this is familiar to you now. Okay. Familiar expressions. Maybe we look for that. These are reciprocals of each other, so that product would give us a 1, right? Cosine times secant would be 1. Maybe we see a quotient rule somewhere. I mean, we're looking for things to do. If there are squares of functions like this, think Pythag. You know, that's a possibility. If you see squared, think Pythag. And in general, generally we want to shrink things, reduce the number of different functions, and we want to transform them into the ones that we want in our answer, right? We need to keep the end goal in mind. We could certainly spend all day on one problem going, all different kinds of routes. And maybe that sometimes can be an issue with proofs. I can get, of my tag students, I can get a proof done in 4 steps versus 15. And I'm not saying you can't do 15. You can do as many steps as you need to get to the answer. What I'm saying is you might want to be focusing on where you're going so that each step that you make is getting closer to getting you there, not just doing random things that we can do. You want to focus on where it is that we're going so that we're making progress towards where we're going. So when I grade your proofs, and that's what this, keep looking at the answer to make sure you're heading in the right direction. I have to read every step that you write, right? If you don't want me to read a step that you've written, you need to cross it out or erase it. So I have to read everything. So, if you're writing things, if you have some right things and some wrong things, you're going to lose points for the wrong things, right? So we just need to be sure that we're doing proper algebra, no crazy algebra, and proper trig substitutions, etc. So are there questions in general about these steps? Any general questions before we start the problems? Okay, let's go to the next slide. I have a few examples. Also, it is certainly fine for us to do different sides. It's okay if you choose a different side than me. That's fine. And you can get to your answer a different way than I do. That's also fine. It's fine. Just as long as everything you're doing is correct, it's fine. So there are a lot of different ways that you can do these proofs. Let's look at number 1. So my choice is to work on the left side or the right side. And I want to think about this, to think about what would be easier for me. So I have to think, would it be easier for me to get rid of a plus or add a plus? To me, it would be easier to get rid of a plus, right? Because what I would do is I would turn these into fractions and I would add them together, so I'd make one term. Because this is one term. I have 2 terms versus 1 term. So I would choose to work the left side. Do you have to? No. You can work the right side if you want to. I'm going to work the left side. And so the very first thing that I'm going to do is I'm going to turn them into fractions. Instead of turning them into reciprocals, 1 over tangent, 1 over cotangent, that doesn't seem to help me where I'm going. I'm going to use a quotient property. I'm just going to use a quotient property. I'm going to turn cotangent into cosine over sine. And I'm going to turn tangent into sine over cosine. Okay, let's try that again. Okay, so sine over cosine. And I encourage you to use these, RHS, right-hand side, or LHS, left-hand side. I encourage you to use that. I don't want you to have to write this over and over again. And if you write it over and over again, I don't want you to be tempted to work on it. You are not allowed to touch one of the sides. I mean, it's your choice, but you're not allowed to touch it. You cannot change it. So you might as well just put RHS, right-hand side, or if you're working on the right-hand side, put LHS for left-hand side. You might as well just do that so you're not tempted into messing with it. So the reason I did here was quotient. Now I have 2 fractions. I want to get them together, so I'm going to need to get a common denominator. I'm going to multiply both of those by 1, and they're going to be different ones, right? I don't have to use the same one every time. So I'm going to multiply this one by cosine over cosine. I'm going to multiply this one by sine over sine. So this would be, or multiply by cosine, so this would be cosine squared over cosine sine plus, I'm multiplying by this one by sine over sine, so sine squared over sine cosine. And this is equals right-hand side, and this is multiply by 1, or you can say common denominator, whichever one you would like to do. Okay, so are we okay? So all I have done is I have found a common denominator. Now I'm going to go ahead and add them together. So I have cosine squared plus sine squared equals cosine sine, and that I just added. I hope at this point we're comfortable and we could see what we would need to do next. Right? Can we see that? Right? We need to have all of those formulas and identities memorized before tomorrow's quiz. Right? It's going to be very important that you have all that memorized, or you're going to have a really hard time doing this work. Okay, so that's Pythagorean Theorem. Right? Cosine squared plus sine squared is 1. And that reason was Pythag. Okay, so we look to see what we have. We look to see where we're going. Well, we're pretty much almost there, right? Those are just reciprocals. 1 over cosine is secant, and 1 over sine is cosecant. So let's use our reciprocal property. This gives me secant and cosecant, and that was reciprocal property, and I'm done. There's really nothing to box in, because there's no one answer, right? That whole proof is the answer. The whole thing is the answer. So there's not one particular thing that we would need to box in. That's our very first proof. How are we doing? We okay? Yes, ma'am. We do. We need to. We do. We either write the RHS for all steps, or we copy this every time. So those would be our options. We need to keep it as an equation instead of as an expression. Okay? All right, let's look at number 2. Okay, I can either try to get, so if I work on the left-hand side, I would want to try to turn this into one term instead of 2. Or if I work on the right-hand side, I would want to try to turn this into one term instead of 2 and this into 2 terms. You see, I have a choice. Here it's pretty even, doesn't really matter. I'm going to choose to work on the left-hand side. Do I always work on the left-hand side? No, it's just working out this way. That's the way these particular problems are working. So I'm going to work this side. And I think we learned in that previous example how one way to get rid of a binomial in the denominator. And that's by multiplying by its conjugate. Right? If I multiply by its conjugate, then it's going to shrink it to one, a monomial instead of a binomial, which is really kind of what we want. So let's do that. So I'm going to multiply this by 1 minus cosine over 1 minus cosine. And that reason is multiply by 1, or you can write common denominator. Now I encourage you to not distribute the numerator. If you distribute the numerator, you might miss something that you could cancel. I encourage you to just work on the denominator. That's the reason that we did the conjugate, right? Was to make the denominator different. So I'm going to multiply the denominator out. So 1 minus cosine times 1 plus cosine is going to give us 1 minus cosine squared. And in the numerator, I'm just leaving it separate. And this was, I actually just multiplied. Okay, 1 minus cosine squared, we know what that is, right? That just kind of jumps out at you. I hope it's jumping out at you. That's Pythag. So I have 1 minus cosine times sine over sine squared, and I just use Pythag. Okay, do we see what to do now? See how we can cancel this sign with one of these signs? So I have 1 minus cosine over sine, and that is, you could say cancel or you could say simplify. and we are where we want it to be, right? We're there. Okay, how is that? We okay? All right, our last one. Well, my choice is to shrink this to cosecant or to make this bigger to make it look like this mess over here. I'm going to choose to shrink, okay? Some students would rather make it bigger, you know, expand it. I would rather shrink this down, to be honest. So that's what I'm going to do. I'm going to shrink it down. Let's see. I have two terms. I need one. So I need to figure out how to get these together. So I'm going to try to find turn them into a fraction, try to find a common denominator. It would be easier for me to turn this cosecant to 1 over sine. Right, that would make a fraction pretty quickly rather than make a squared on the bottom or some kind of a hybrid. So what I would do is I would turn cosecant into 1 over sine. So I'm going to have cosine squared over sine plus sine, and that would be reciprocal. Now, some students don't like different variables other than x. You know, this is a theta. I encourage you to leave the variable theta. Don't change it. I'm just, you know, we're just training for the AP Calculus test. They're going to use different variables and you need to keep them. Whatever variable they use, you need to use. So let's just get in that habit. It's a theta, leave it a theta. Okay, don't change it to an x because we like x better. I know I like x better too, but we don't want to show favoritism. So we're just going to keep it a theta. All right, so we look at this and we think, well, let's see. I have a fraction. I need this one to be a fraction. So what should we do? Let's kind of think this through. I need to get a common denominator. So I'm going to multiply this one by sine over sine. Right, multiply by sine over sine. So I have cosine squared over sine plus sine squared over sine. And this is multiply by 1, or again you can say common denominator. Okay, let's go ahead and add them together. So I have cosine squared plus sine squared over sine, and that's just adding. Okay, can we see what's next? Hopefully we see cosine squared plus sine squared. Right, we know that's 1. That's Pythag. So 1 over sine. And I just use Pythag. Look how beautifully it's turning into what we want it to be, right? 1 over sine is cosecant, right? That's a reciprocal. So we have cosecant, and that's reciprocal. So let's talk about these proofs just for another moment, and that is, I am never going to give you anything that is false. It will always work. So if it's not working for you, you need to understand that there's something that you're not seeing or doing, because there isn't one that I'm going to give you that's impossible. Okay, they're all going to work. So we just need to keep that in mind as we're working through. It's going to work. And I have a particular goal that I'm looking for. I want to, you know, kind of continue to work towards my goal and use strategies to get me to the goal, not just to do random trig things or random algebra things. Okay, any questions? Are we okay on our very first day of proofs? Now, the second day of proofs, I don't have any notes for that day because, I mean, it's just proofs, more proofs. We're going to get to spend an entire day on just working on proofs. Doesn't that sound delightful? That's like going to be Friday, too. Yes! It's a Friday where we're just going to work on proofs. Yay! Yay! It's going to be fantastic.